بلو معايا؟ أنا إبراهيم موسى. معلش البرزنتيشن هيبقى بالإنجليزي عشان بس بصراحة البرزنتيشن بالعربي قوي بس بيبقى عربي يعني فسوري يعني. I'm Ibrahim and today we're going to talk about Android forensics and custom recoveries. Okay, let's quickly start with the agenda. Basically, we start with the introduction to Android. What is Android? What's even the meaning of the word itself, Android? The system architecture, the memory architecture of Android devices. Then we'll move on to something called custom recoveries. What are the custom recoveries or the stock recoveries, or what is the word recovery on the Android world? Then we move to the relation between custom recoveries and forensics. How can we relate between custom recoveries and forensics? We'll talk about the achievement that we did, the goals that we achieved, and the challenges that we're facing. We'll end with the conclusion with a small demo on an Android device. Okay? So let's start with what is Android. So please, anyone have an idea what is Android?
It's an operating system.
Operating
system. Linux.
Cool.
Okay. And it's being developed by Google.
Yeah, it's pretty obvious. I mean, Android is an operating system, but before that, the word Android itself is robot with a human appearance. That is the word itself. So that's why the logo actually looks like that. And yes, it is an operating system currently developed by Google. Okay, moving to the market share of Android. In the US, the market share of Android around 51%, which is higher than the iOS, which is expected. But even more in other countries like Europe and Africa or Middle East, usually the percentage is 70% people are using Android and like 20% or 21% they are using iOS. And I'm sure that in Egypt, more people are using Android than iOS, and there's these different Chinese vendors. Okay, so this is about market share. What we're trying to do now, just trying to have like a quick introduction about Android. Okay, moving on to the Android architecture. So we said it is a Linux operating system. So what is the architecture of Android? Basically, we have the Linux kernel in the bottom. And on top of the Linux kernel, we have different libraries, and they are everywhere. I mean, this is still now, it's normal Linux. We have the SSL, libc, SQLite. Of course, it comes with some pre-installed libraries like SQLite because it's used by applications. Okay, and then we have this Dalvik machine, Dalvik virtual machine with its core libraries, and everything else is usually operating on top of the Dalvik virtual machine. So usually the applications that you develop are usually on top of the Dalvik virtual machine. Okay, so it's simply a Linux system. On top of it, different add-ons and different applications. Okay, worth to mention here that the security in Android systems usually are based on the permissions of Linux. So when you create an app, each app has a user, and this app is jailed into its folder by the permissions. Okay, the app can't see other application files because of the permissions. So the security of Android is basically the permissions. Okay, moving on to the Android memory. So when you have your device, whether it's Samsung or Nexus or LG, well, the memory is a NAND physical memory. It's one piece, but it is logically it is divided into different partitions. Okay, some of these partitions are mandatory, and the phone won't operate without them. Okay, for example, the boot partition, which has the bootloader. Okay, and this is a mandatory partition. The system partition, and it is a read-only partition. It has the operating system, the Linux operating system. It is always mounted as read-only. So even if you manage to root the device, usually you won't be able to create or write files on the system unless you remount it as read and write permissions. And we have the data partition, and this is like the most interesting partition because all your data is in there. Everything, the SMSs, the images, the notes, WhatsApp, Viber, Facebook, everything is in data. But again, on top of this file system, you have the permissions to protect you. Okay? And we have this recovery partition. Well, in the picture it looks bigger, but actually in the reality it's kind of like very small. It's like 7 megabytes or 10 megabytes, the recovery partition. Okay? What is the recovery partition? Well, we'll talk about it. But for now, let's say it is a minimal Linux operating system. Okay, we'll talk about it in the coming slides. Yes, and here we move to custom recovery. So before I explain what are custom recoveries and what is the recovery partition, tell me when you hear the word, what you get for like a recovery partition, what would it be?
So deleted information will be set in that directory.
Deleted information? Well, because it's recovery, the word recovery, no, it's not that way.
ممكن يعني مش عارف بس انا بقول ممكن تكون مثلا زي الويندوز ريكفري يعني بارتيشن اريكفر منها السيستم او مثلا اوبريتنج سيستم صغير في حاله الفيلير بتاعت الاوبريتنج سيستم الاندرويد اقدر ادخل على السيستم الصغير.
Exactly. This is the stock recovery partition. It's usually a minimum Linux operating system that is used for maintenance and backup. So this is the definition. It's an Android, a modern Android service that puts in a minimum Linux environment. It has everything. It's file system and it's kernel. Okay. And why it is used? Why the stock recovery is basically for maintenance and for updates. Okay. Yeah, for maintenance and updates. And this is the picture of the recovery. I'm not sure if you can see it very well or not, but if you can read, we have these three functionalities. Apply updates from ADB, okay, and we have wipe data / recovery reset, and this is what's called hard reset, okay. So when you mess up with your phone and you want to get back everything, you just open the recovery partition and do wipe and delete, okay. So this is the recovery image, and this is the 4 functionalities that we only have, okay. So let's move on. But yeah, before we move on, this recovery image or recovery partition, again, we say that it is an operating system, a Linux operating system. So this is the picture of it. If you have this recovery.image file, if let's say we managed to have this recovery.image file, this would be the architecture of the image. You have a header, and this header is some text value that says there's the kernel and it starts at point X, and this is the RAM disk and starts at point Y. And you simply, when you boot, you take this RAM disk, put it in the RAM, the random access memory, and you boot with the Z image or the boot partition. Okay. Now we understood what's custom recovery. So basically, each Android phone has a custom recovery. My phone has a custom recovery. Samsung S3 has a custom recovery. Your phones, if you're using Android, has custom recovery, stock recoveries. Okay, that recoveries that comes pre-shipped with the phone. Okay, and if you one day made an update, if you made an update for your system, you find that your system reboots, right? And when it reboots, it shows like an Android logo. So it actually rebooted into the recovery partition to update your system. Okay. Now let's move a bit to the digital forensics. Okay. Now we understood the recovery partition. Let's go to the digital forensics and then we link between them. Okay. So I'm not gonna dive so deep in the digital forensics. But we will just define it very quickly. It's a branch of a forensic science. It actually encompasses the recovery and investigation of data, and usually in digital devices. Okay. So if you're working in the forensics field, you're responsible on the recovery and investigations. So what do you mean by recovery? Is we'd say that in the process, it's something called seizure, okay, or acquisition. You have seizuring the device. For example, when you have your Android device, or when there is a case and you go to the scene, you usually, if the device was operating on, you shouldn't switch it off because you want an image of the memory. So the first process or the first step is seizuring, and then data acquisition. And what I mean by data acquisition is that to acquire the data, to collect the data. Okay. So let's say you have this phone. If I want to do an acquisition of the phone, so I want to copy everything on the phone, right, and put it on my hard disk so I can examine on it, right? And the same with the laptops. If you have the laptop, you'll simply open it up and then take the hard disk, connect it to your machine, and start taking an images from this hard disk. Need to mention here there are 2 main types of the data acquisition. Something called logical data acquisition and something called physical data acquisition. Okay, we'll talk about this in the upcoming slides. The third step is analysis. Well, logically speaking, when you have after you got the data, you need to analyze the data. For example, if you're looking for some SMSs, you're looking for some emails, just analyzing the data. And then the last thing is the reporting. So these are mainly the main 4 steps of any forensics design, forensic science, okay? So now we understood, like, okay, how this can be linked to the custom recovery. Okay, now we understand what is forensics and what we can do. In forensics, you usually do these 4 things, okay? But before I continue, I'd just like to ask you, which stage do you think it's the most important? Analysis?
Acquisition.
Acquisition? Why?
Because it's if I don't have the data, I can't do analysis, I can't do reporting. It's the most important thing is to get the data in the right way.
Exactly. This is the most important thing, and more importantly, it's the most sensitive case, because if by any means you acquired the data incorrectly, and it happened that you went into a court to testify, the first question is, how did you acquire the data? So if you acquired it incorrectly, the data won't be, I mean, you can't use it as a proof, okay? Or as an evidence. Okay, now we move to the relation between custom recoveries and forensics. Okay, there are 2 things in any Android device, and these are the main bugs in Android devices, or most Android devices, most vendors, let's say. We understood that the recovery partition is a normal Linux operating system, right? So if I managed, okay, to boot into my system, my own recovery partition, would I find any difficulties to mount other devices or to mount other partitions, like data partition, and copy the data from it? Logically or physically or whatever. What do you think? I mean, if I managed to, by some way, to have my own recovery partition, and we saw these 4 functionalities, right? But instead of these 4 functionalities, we had like 10 functionalities. One of them, logical acquisition. Would it be possible for, what were the problems that we would face? To copy, for example, the...
As a Linux operating system, it would be okay, it's supposed to be okay to mount other partitions.
Why?
Because it's a Linux functionality.
Yes,
there is
this is another, I mean, when you boot into the recovery, this is another partition, and this is another partition, and this has its own permissions and everything. You know, the permissions are with the file system. So even when the system is dead, there are permissions. So, is it possible or not? We'll see. But let me continue. One of the main, but I mean, there is no encryption, right? There is no encryption. Usually in an Android system, there is no encryption. How many of you are using encryption, full disk encryption on Android, on his Android device? Perfect. Like 2% or 3% of people only use full encryption. So you don't have full encryption. So yes, I mean, if you managed to boot into another system, okay, by any means, you can see the other, like the main system, like dead, and you can take anything of that system. Given that you are with that system that you booted, you are the root. Okay? So this is one thing, there is no this security, file system is not encrypted. And usually people don't tend to encrypt the file system because it usually uses the battery. The battery consumes the battery very, very fast. Okay? The second thing, the bootloaders. Usually the bootloaders, especially with Samsung devices and some of the Sony devices, the bootloaders are not locked. What do we mean by locking and unlocked bootloaders? We'll talk about this in the challenges. Okay? So we come up with this hypothesis, as you say it exactly. If we manage to develop a custom recovery with forensics functionalities, we'll be able to forensically analyze any mobile device. Okay? So what we want to do, develop a custom recovery and with forensics functionalities, right? So we want to know how to develop and what are the forensics functionalities. Okay? So, yeah, so let's ask this question. What are the forensics functionalities? I mean, let's say you can develop this custom recovery. What would be the forensics functionalities that you want to develop? Any functionality? Imaging, which is like logical acquisition or physical acquisition. Any kind of, both of them. So these are 2 forensics functionalities. What else? Imagine if you're in a case and you have the device. Yes, these are one of the main things that you should do. What else? Okay, we can say, for example, yes.
User recovery applications.
Yeah, if you have the image, you can work on the image directly. So basically, the main functionalities are the imaging, physical, and logical acquisition. Okay. So when I had this question in front of me,
If it's compliance or jailbreaking, for example.
jailbreak, you can't tamper the device a lot because this is not okay with the forensics stuff. So you shouldn't tamper the device. Okay. In taking the image or physical or logical acquisition, you don't tamper the device. Just take a copy. Okay. So I had this question, and I wanted to choose the functionalities so that I can proceed. So I went to a company called Via Extract, and this company is, Via Forensics, and this company is the leading company, or the most leading company in mobile and forensics. Right? They have an application called Via Extract, and this application, they say, it can do a lot of functionalities. Let's see these functionalities. Passphrase / pattern / bypass. I wrote it that way because they wrote it in their website that way. Okay, though we will see the all one thing. Okay, logical data acquisition. Okay, and physical data acquisition. Routing, though this shouldn't be a forensics functionality, but they give you more functionalities. Okay, and ADB shell. You know ADB shell, right? You know the ADB shell. So if the device doesn't support or the ADB shell is not enabled, if you use the Via Extract tool, you can enable it. Okay? Cool. Because if I enable the ADB shell, I have SSH, or like I have a shell, and I can do whatever, right? If I have the right permissions. So these were my forensics functionalities. Okay? And we'll see how we managed to achieve this. But let's go a little bit back for one step. We said in the hypothesis that we need to develop a custom recovery, right? So how can you guys develop custom recovery? Basically, there are two ways. If you either take a stock recovery and you start from scratch, or you take like a good custom recovery and you build on top of it. Okay? Of course, we don't like to reinvent the wheel, and we would like to start from something that has good functionalities in it. Okay? So that was. Have you ever heard about CyanogenMod? Okay? We'll see now how this helped us. But first thing, we need, of course, Linux / Mac OS system, because we need GCC to compile. Okay? We need CyanogenMod, and why CyanogenMod source code? They have their own. They modified the Android operating system, and they have their own CyanogenMod operating system, and they have the custom recovery, which is called Clockwork Mod Recovery, and it is very, very good recovery with good functionalities. So, and the source code is on GitHub. So you simply take this source code, download it to your machine, and then add whatever you want, compile, and then just flash it. Okay, we'll see how this happens. But we know where to start, right? This is the source code. Just go CyanogenMod, download the source code, and you're good to go. You have the source code of a good custom recovery that you can build your own functionalities on top of it. Okay. So what else we need? Again, we said develop the forensics functionalities and build your own custom recoveries. Develop the forensics functionalities is the actual developing, the actual writing, when you write the code. Basically, the CyanogenMod source code is written in C. So for you to develop more functionalities and to extend the functionalities of these custom recoveries, you have to know, you need to write how to write C. You need to know how to write C. And to build, just to compile. And CyanogenMod made it very, very simple. Just write and make a statement, and it will compile everything for you. Okay? And then flash it on the device if you have the correct device configuration, and we'll talk about this later. So these are basically the 5 steps. The first one is very simple. Second one is very simple. Third one, you know some C, just write whatever you want. We said imaging, and we made like these functionalities like routing and deleting the password and everything. We talk about each functionality and how can you develop it actually. Okay, and so this is like the only step that takes time or it takes effort, and this just make, okay, just compile, do nothing, and flash it. Again, you have the recovered image. Remember that we saw. Once you're done with this step, you have recovered image file. Okay, you just take the recovered image and then you flash it. And how to flash it? There are a lot of tools. There's a tool called Fastboot, Okay, and this is the tool that acts with the fast bootloader itself, the bootloader of the device. Okay, and we have tools in Linux called Hindi-O, and these work with Samsung vendors. Okay, you have a lot of tools. So these tools download, install, just some code, just a command. So it's not very tough. Okay, so we know how to develop, right? Like if I want to develop now, I just install the Central and start development, right? And we know the goals. Our goal is the forensics functionalities, right? Let's see if we're going to write code, what we write for the forensics functionalities. Okay. So, but before we continue, I'd like to make sure that all this is based on the idea that we managed to boot into another operating system, right? Because since we managed to boot, it's exactly the same as if you have if you forgot your Linux password, okay, and your Linux password or Ubuntu machine was not encrypted, okay. So what you will do? You will boot from a flash disk, right? You will mount everything, and it will take the data. Exactly, it is exactly the same. You just boot from another partition, okay? So this is the main idea. Okay? So now we go to the develop forensics functionalities. Again, logical acquisition. So now let's define what is logical acquisition. Okay? Logical acquisition is basically when you take like the data, or you acquire the data, or you copy the data from the point of view of the operating system. What do I mean by that? Let's say you have a file on your desktop called passwords.txt. Okay? And inside that file, you have a lot of text. Okay? If I manage to boot from another machine, okay, I'll find the file on the desktop and I can copy it, right? Simple. But if you deleted the file from your desktop, the file actually is not deleted. I mean, just the pointer to the file is gone. So from the operating system point of view, there is no file, right? So if you're going to take a logical acquisition, you will lose this. But if you manage to take something called the physical acquisition, we'll see it now.
Bit image.
What?
Bit image.
Exactly, a bit image, which is called a physical acquisition. You take the hard or the device bit by bit. Okay? So you can recover everything. Okay? So logical acquisition. So let's say we have a function called acquire the device logically. Okay?
If I put it from another partition, I will lose the live application, the memory, the RAM.
Yeah, the RAM. You usually lose the RAM in the mobile device because you need to reboot to have this recovery partition. But it's better than nothing. You usually will lose the RAM, but I mean, you have the data. You still have the data. The big chunk of the data is in the memory, not in the RAM.
I think the live application is important.
It is important.
Case.
It is important.
As evidence.
If you have a phone, and I mean, if for example, it managed that you seize my phone and it is running, okay, you won't be able to get the RAM because it's locked. It's you won't be able to, right? So it's very difficult. It's still a challenging thing on mobile devices to acquire the RAM. Okay, unless the phone is not locked, so you can do it. Okay, so the logical acquisition. If we want to develop this function, what we will do? Well, simply we will we'll just mount the device. Okay, so let's say that we'll do mount. This is function, and we open this function type /data. This will mount the data partition, right? And then what I'll do, I'll call function system, okay, and cp-r, copy everything recursively, starting from the root direction, and place it in. And here comes the question: where should we place it?
My computer.
How? I mean, this is not. I mean, even if it was connected to your machine, it is the recovery partition. There is no connection between them. I mean, it just.
Can you do it on extended card?
On SD card.
Yep.
SD card.
SD
Yeah,
card.
this is a good way. So basically, you will just mount the device, okay, and mount the SD card, cp-r everything, and put it where? To the SD card. That's perfect. And there is this thing that I bought. 1 second. Yeah. This flash disk. I'm not sure if you're familiar with it or not. Okay. It has, from here you can plug it into any PC, okay? But from the other side, you can plug it to any mobile phone. So you can get 32 gigabytes. and just format it and plug it to the phone and you get it. Okay? So this one, right? And you just mount it again and work with it. So this is the logical acquisition, very simple, 3 lines of code. And I swear, it's just 3 lines of code. Okay? And then you have the physical acquisition. Okay, how can you do the physical acquisition?
I think you need a device to connect the mobile and another device to copy all the content from the
we have the other device to copy too, which is the SD card or either the flash disk. But how can we do it from the machine? How can I access the hard disk?
There is a device has 2 places. First for the mobile and another disk to copy all the content from the first device to the second.
Yes, this the second device, which is the SD card, but we need just to copy it from the phone, and it's very simple.
We can use the drive.
Don't forget that we are operating on top of Linux. So I have everything. I'm operating on top of the Linux system as a root.
We can use the SD card drive and copy all the SD cards.
Okay, how many here they have used Linux before? Most of you. Okay, if you went to that div folder, you'll find a lot of devices, right? Including your hard disk, which is usually div SDA1, SDA2, and you find SDA and then below it SDA1 and SDA2, the different partition. Right? So these are the driver. I mean, Linux gives you the opportunity or give you the chance to have the driver. You're not mounted. It's not mounted. You just have the driver. Okay? And there's a tool, very known tool, called DD. I'm sure you're familiar with it, right?
Yeah.
This tool, you just give it the name of the device and the destination. It will copy bit by bit from the device. So we'll just, if you want to mount physically the data partition, what we'll do, we will just DD, yes, from exactly input file and then OF the output file. And this, okay, amazing. What I did it was exactly this, because I didn't use the normal DD. There is a version of the DD developed by Department of Defense in the US. It's called DC3D. It is a specific version developed basically for forensics. Okay, so when it acquires the data, it acquires it to make sure it is completely correct. Okay, it does checking and has like it checks some to make sure that it copied everything correctly, bit by bit. So I compiled this. Again, I have Linux and I have my own Linux. So all I need to get the source code of this DC3D. Okay, given this source code, I will compile it to the architecture of the mobile devices. Okay, and just after compile it, I have this binary. I can play with the binary. Okay, so this is the physical acquisition. Very, very, very simple. Okay, routing. How can we do routing? Let's say, of course, this is not a forensic functionality. But if you want, let's say, if you want to root the device, how can you do it? Anyone?
Depends.
I mean, I'm sure you use a lot of Linux. How does the root work?
It depends.
You do sudo su.
Yes.
So?
I can log in as an admin.
Okay, how can you? I mean, if you want to root the device, I mean, if you're booting from the recovery, you are root already. You are already a root, so you don't need to root. But the rooting for like after the phone is restarted and everything, you still rooted in the phone. Okay, and just to give you an idea, I mean, if you can do rooting, you can do a backdoor, right? You can just. We'll see how to do rooting. It's very simple. Oh, sorry. So yeah, how can we do routing? Well, it is very simple again. No, not the shadow file. When you root, there is something called the SU file, okay, the SU binary. So the entire idea of rooting in Linux is that you have this SU binary in the correct place with the correct permissions. Okay.
And you add the user as a sudo code.
The S flag.
Yeah, dash S.
Exactly.
Makes you.
Exactly.
Yeah.
So if you have this SU binary, we can root, right? So yeah, how can we get this SU binary? Very, very simple. Everything is an open source. You go on GitHub, get the SU source code, you find it su.c, get it, compile it, and then you will have it on your phone. You will have it in your recovery. Now the question is, how can I make it permanent? How can I make it to the real operating system? Remember the memory diagram? Okay, just
Slash proc.
easier than this. I want so that when the device boots normally, I still have the SU file and with the correct permission with everything. How can I do it?
Replace it.
Exactly, simply. Mount the system partition. You remember the system partition was read-only, right? Now you are root. You can do everything. Mount, read, write. And you just go. I can't remember the path, but it was like...
System bin.
yes, exactly. System bin. You would place your SU, give it the correct permissions to 664. I don't remember. I can't remember them, but I wrote them. So you just give it the correct permissions. You're good to go. You can do the same with the backdoor. Just have it, put it there, make it root, you're good to go. Okay? So this is routing, and ADB is very simple. Again, you'll get the source code, compile it, you're good to go.
Can we dump the RAM before the
You
position?
can't dump the RAM. Because, I mean, if you have this device now, you can't dump the RAM. We'll see how I mean, till now you don't know how to put the recovery on the phone, right? Till now we don't know this. We have the recovery on the machine. We know how to get the recovered image. Now we know how to develop the forensics functionalities. We will have to compile it. It's very simple. To build the custom recovery, it's very simple. Basically, you have two things. If the device is known, what do I mean by the device is known? Have you ever visited the website of CyanogenMod? You did? There's something called build guides. See it? For many phones, right? Which is the operating system. CyanogenMod is working on many devices. So if the device that you're targeting is one of these lists, is one of this list, you're fine. So if the device was known, for example, Samsung S3, okay, this means that all the device configuration, or like each device has its own differences. For example, my phone, let's say it's an Nexus 4, okay, has different camera than the Samsung S3. So the drivers should be different and everything should be different. So this is something called the device configuration. If someone has already compiled a CyanogenMod OS for Nexus 4, I don't need to get this information again. I'll just get it from the repo. So if the device is known, I'll just go CyanogenMod and build it from the website. You just find the website, the steps, one by one. I would like to open the website, but maybe after we're done, just to show you the steps. It's very simple. Okay? Or you would like to see it now? At the end? Okay. So you just simple. It's compiled. Okay? Now we have the recovered image, right? We need to flash it again. Okay. But yes. How about the new devices?
Chinese device.
Chinese device. How about this? What should we do? I mean, if the device is not in CyanogenMod source code, what should we do? Okay. So, if you want to think about this together, how would we think?
We can develop the drivers.
Okay. Before this, I mean, the first question is, what are the information that I need? Right? The exact information that I need. Okay? Well, you need these three informations: so partition info, board configuration, and kernel. Okay. If you didn't find any of these information, you'll mess up with your device, and the device might not boot. Okay. Usually, the kernel is an open source, and any vendor should give you the kernel. Samsung usually releases its kernels because it's a Linux operating source, and this is licensed under GPL. So the vendors have to give you the kernel, okay? So this way you can get it. You also can get it, I'm sure you're familiar with a website called xda-developers.com. And every day on that website you see a different ROM, right? A new ROM for that device, a new ROM for that device. You just take the ROM and take the kernel from it. That's all, okay? The board configuration and the partition info, for example, if we say that this is the device we want to acquire, if I have my own device, which is similar to Samsung S3 or Samsung S4, whatever, from my own device, I can extract all this information. Okay? How to extract them? There are different locations. You just need to know where are the locations of them and just read them from your own device, and they will be the same. Because the same configuration, the board configuration and the partition info, they are the same for Samsung S3. Okay? So we said that information gathering, we say already builds these are the three main things: already built stock ROMs. Okay, even if you have the already built stock ROM, you know, in for example, Nexus 5 and Nexus 4 and Nexus 6, usually Google places the image on their website, right? The .img or whatever. So if you take this stock ROM, you can extract all information from that stock ROM. Okay, the boot configuration, the partition info, everything, because that ROM needs this information to flash itself, right? The same with your recovery. You need this information to flash it. Pulled from rooted devices. If managed, you get a root device. For example, there was a vulnerability in an application that's running as root, and you manage to root the device, you can pull this information, and the same information can be, it is okay to use it with the other old devices with the same vendor and the same model. And then mobiles are similar. This is a very tricky thing. For example, let's say S3 just got released today, but I have the board configuration and everything for S2. They're both almost the same except the camera. Okay, so maybe I'll use the same configuration of S2 with S3. I need to wrap up because it's telling me to finish. Okay, I'll wrap up. Yeah, how much possible you will get device configuration, because this is one of the challenges that you will meet if you're developing for new devices. Like 90%, you will always find a ROM somewhere in the internet about that device. Okay. To flash, for Samsung devices, you need an open source code called Hendiol, a tool that you can use it to flash. Just the tool takes, a normal tool can be installed in Linux. The first argument is the location of the binary, and that's all. You just connect your device. Okay, but you need to boot your device from something called the download mode in Samsung. And how can you do this? Just the power. There's like key combination. Okay, for each device has its own key combination to open into the bootloader mode. Okay, and for devices like Fastboot, there is another tool called Fastboot, and this works with Samsung, HTC and Nexus. Okay, and Sony Xperia, Sony vendors usually. And there's HBoot, and this working with HTC, some of the mobiles. Okay, I use Odin and Fastboot. Hendiol and Fastboot. Testing. Okay, this is what I told you, but what I tested actually, I did manage to have this custom recovery working with a lot of devices. Some of these devices is Samsung S2, S3, S4, Samsung Note 1, Samsung Note 2, and recently I have tested in Samsung Note 3, and it did work. So the same technique worked with these devices, and that was tested. Okay, I tested also with a device called Oppo N1. It was a Chinese device. Okay, I just had to get the device configuration, everything, and it worked perfect. Okay, I think it will work with 90% of the Samsung devices, because Samsung, they don't have bootloader blocking mechanism. So let's define quickly what is the bootloader blocking mechanism. Is that if I give the bootloader the image of my recovery, the bootloader usually there's like this if condition that it checks if this recovery image is signed or not. You know, the digital signature. So if the image is signed by the vendor, so it's a trusted image, so we can use it. Devices use this like HTC, Sony, they use signed recoveries. So you basically can't just flash your own custom recovery. Okay? If you did this, the device will automatically wipe everything on the phone. So you lose everything. That's why if your device was bootlocked, you have to unlock the bootloader first, and in that stage, if you tried it before, you will wipe everything, and you have to take a backup before you do this. Okay? And Sony devices, some Sony works. I mean, but I didn't try it yet. I read online that Sony Xperia Z1, they have this signed signature, but usually, or sign mechanism, but usually it's working with the main operating system. So you can't override the main operating system, but you can override the recovery. Okay? HTC, usually it's not working with HTC or Nexus. I didn't bypass the bootloader. Okay? So here comes with the challenges and goal. I think you can see now the challenges and the goals. The challenges is that the bootloaders are locked. If you manage to bypass the bootloader, that would be a very important thing. Okay, and you can apply it. conference as DEFCON and Black Hat. Okay, if you manage to bypass the bootloaders and device configuration, but usually you will find the device configuration. These are the two main challenges that I still face with different devices. If I have a new device, I need to get the device configuration and the bootloaders. Okay, there are different tricks to bypass the bootloaders. Finally, okay. Now I'm done. Just have this acknowledgement. I need to acknowledge some people. They helped me a lot in this project, and now I can. If you have any questions, any questions? Okay, would you like to see a quick demo?
Yes.
Okay. So the demo would be, of course, I won't be able to do logical acquisition because it will take time because it will copy the 4 gigabytes of the phone. Okay. But a good demo would be is to bypass the battery /bin/thing, right? So let's open. Okay, so I'll use a technique that forgot your name. Sorry, I'm bad with names. Sorry, because I'm very bad with names. I'm sorry. So the technique was to open FaceTime. Where's FaceTime? Okay. Yes, to open FaceTime so that you can see the phone. Okay. So this is the Samsung, and it is supposedly locked. Okay. Okay. Now I will boot into the recovery partition. I'll just click and click first unlock it. Okay. Then I'll switch off the phone. Okay. Okay. Okay, for me to boot into the recovery, I'll just click on the bottom up with the power and the menu. I'll click 3 of them, okay, until the logo of Samsung appears, and then I will leave the power. I'll keep pressing on the other 2 buttons. And now I'm booted into the recovery partition. This is the recovery partition of CyanogenMod, which is called the Clockwork Mod Recovery, and I added different functionalities to it. So let's go into. There is advanced, and this option, I'm sure you don't see it. It has, okay, it removes the battery. Okay, so I'll choose this option. Okay, choose, and then it shows me. It tells me a message here that if you're sure, press volume down. Okay, and I quoted this message. So volume down. Okay, now it's done. The pattern, I'm sure you can't read this. The pattern is removed. Enjoy. Okay, so let's restart. I'm sorry about this. I didn't want to do a demo, but أنا عارف المشكلة دي. Okay, now we're booting. Okay. Yeah, there is still pattern, right? But please try any pattern. So the same thing works with anything, the pin, any technique that you use. So it's all the same thing. Please, if you have any questions.